Hi, this is Ben Armstrong, a Senior Program Manager on the core virtualization team working on Hyper-V, and just want to take some time to talk about the Hyper-V architecture. One of the things that we often get asked is when you sit down and you use Hyper-V, it feels just like, you know, another virtualization program running on top of Windows Server. And yet, when you read all the material, we're talking about it's hypervisor, you know, it's bare metal, and people kind of have this conflict. And I really like this slide that we have here because it lays out what actually happens. So the first thing you have is you have the design for Windows Server hardware down the bottom, and this is important. You know, we can run on pretty much anything that Windows Server runs on. I say pretty much because we have the two requirements. It's got to be a 64-bit platform, and it's got to have hardware virtualization support. So either AMD V or Intel VT. Now, what happens, and this is what confuses people, is this first little process here. You get your hardware, and the first thing you do is you install Windows Server 2008 on it. And at this stage, it's a plain old box running Windows. Once you've done that, you're then going to go into the role management tool and say, I want to enable Hyper-V. We're going to put the Hyper-V bits down on the box. And then when you reboot the system after installation, a magical transformation happens. And as we're coming up and booting, we will actually load the Windows hypervisor underneath the operating system that you view as being the main one on the box. And at this stage, it's now become what we refer to as the parent partition. And the parent partition is technically just another partition on top of the hypervisor. Now, the difference between the parent partition and what you think of as virtual machines is that the parent partition has direct access to the hardware. It has direct access to the memory. But its access to processor resource and other system resource, timers, etc., is being managed by the hypervisor. And the hypervisor is in full control of the parent partition and could revoke any of those accesses at any time. So once you have the parent partition up and running, you also have a bunch of our management software running in the parent partition. You can use this to create virtual machines. And virtual machines are what we call child partitions because they're created on behalf of their parent. Unlike the parent partition, however, these virtual machines don't get direct access to the hardware. They get to use the CPU, they get to use the memory. That's all managed by the hypervisor in this case. However, for the hardware, there are a couple of models. The first one that we're looking at here is if you're running a supported Windows operating system, you'll install the integration services inside the virtual machine, and that will get you the VM bus driver and the VSC drivers. Now, this is our new high-performance I/O architecture, and this gives you the best performance possible, and it also gives you the most direct path from the virtual machine to the physical hardware. The alternate one is if you're running a non-supported operating system that it doesn't have these drivers, isn't aware that it's running on top of a hypervisor, in which case you're going to be going through our emulated devices. These are compatible with most operating systems out there. However, they're nowhere near as fast as the VM bus-based drivers. And finally, if you're running a supported Linux virtual machine, with the Linux integration services, we have provided a VM bus driver and Linux VSC drivers so that even running Linux, you can get the access to the high-performance I/O subsystem in Hyper-V. And that's it. Have a nice day.